Welcome to the one and only Structural Engineering Podcast. This week we sit down with a principal at Fast Epp, Ian Boyle. We talk a lot about mass timber, Fast Epp's new home office building, and their general design philosophies, what makes them as good as they are. We talked for a while and it didn't feel right cutting out all that much, so this episode goes a little longer than usual. So with that, we'll have a very short intro. This is the end of it. Here's Ian.
My name is Ian Boyle. I'm a principal with Fast Epp. I've been working with Fast Epp for about almost 20 years now. And it's just been a really rewarding experience working with them. Came to them a few years after graduating and had the opportunity to work on some really exciting projects. Fast Epp has been around for 35 plus years or so. And our head office, our home office is in Vancouver, BC, Canada, but we have offices in Seattle, New York, Edmonton, Calgary, and Frankfurt, Germany as well, which has been fun to sort of cross-pollinate some of the European technologies and ideas.
To get some background on the company, I read a bit about their founders and the work they do from an article in Canadian Consulting Engineering magazine. I'm going to paraphrase a bit here, but working with Canada's most gifted and award-winning architects allows Fast Epp to work on highly unconventional buildings with irregular volumes, customized parts, and careful detailing. Here's a quote from Paul Fast on the drive of the company to push beyond function into aesthetic. "The general requirement of engineers is that you produce a technically sound design that is in conformance with the codes and which is economical and practical. We like to add the third dimension and say we also think it should be aesthetically sensitive and viable." We ask Ian what he sees as the core competencies behind the company.
Yeah, well, I think we're known for exposed structure and certainly more of our timber and hybrid design. We work in all materials. I think we work well in all materials, but we certainly have an affinity for timber and timber design. We use materials where they make sense. So we don't, just push a timber agenda, but oftentimes timber does make sense in many projects. So you'll see a lot of our projects, especially on our website, that feature that.
It's definitely, I think the thing that Fast Epp pops up in the news the most for is this mass timber, but obviously mass timber right now, as we'll get into, is a popular material. It's a material that makes sense in a lot of cases. We'll discuss that a little more coming up here. But so Fast Epp is a really unique firm. Zach and I were all over you guys' website for the last couple of days. I think it'll become obvious as we go through the interview. But the first thing I want to ask is when someone goes to your website, they are met with the expression practical, holistic structural design. What does this mean for you guys?
Yeah. Well, holistic design means different things to different people, but we really see it as the integration of all the consultants, structure, architecture, mechanical, electrical, plumbing, all of those consultants and trades working together and making the project better. In integration of those elements whenever possible makes and helps to the success of the project. But we often want the structure to do more than just support floors or roofs or lateral. We want it to do double, triple, quadruple duty in some cases where we expose the wood or whatever the material is. Maybe incorporating some acoustic baffling into it, lighting, prefabricating some of these elements. We've had some good successes with that. I guess, on the practical side, we say practical, we mean economical. We pride ourselves on being economical designers, even though some of the stuff, that's published and on our website looks quite fancy or elaborate. It really comes with a basis of a practical approach, constraints-driven design where we want to keep things economical, design close to 100%, given that we know the code has a lot of strength factors and load factors already built into it. So designing right to the edge is a good way to keep buildings economical.
Yeah.
All right, now that Max has gotten going all over the place, Fast Epp appears to have a great relationship with architects, as you've discussed. Can you tell us a little bit about how you approach collaboration with other consultants?
Yeah, and architects that we work with know that we push for early involvement. That letting the structure to some degree help inform the design, the building layout, the shape, and then just being really open to ideas. I think that architects really appreciate that in engineers. Not just putting down your foot saying no, this is outside of our approach. So we like to collaborate in that way, and with all of these remote meetings, it's been a bit more challenging. But excuse me, with touchscreen technology and being able to sketch things in real time with the designers, architects on the other end has been a nice tool to sort of foster that short of sitting across the table and really bouncing ideas off of them. So a lot of our collaboration does come with sketches and prelim design. You take a design back to the office, crunch a few numbers, then come back to the next meeting and start sketching out some of those ideas. That's been useful.
That's awesome. Yeah. So do you guys find with that approach that the structural engineer, you guys need to be in on that process fairly early on with the architect?
Yeah, the earlier the better. And I would say, especially as it relates what we were talking to earlier with mass timber buildings, that to make mass timber buildings very efficient and economical, a structural engineer needs to be at the table very early on to help inform the DFMA, or the design for manufacturing and assembly of those manufacturers, to help inform what the building shape is, what panel sizes are best suited for different conditions, that inform the building shape, building size, unit layouts, that sort. So yeah, we definitely push for as early as possible involvement in all building types.
I can imagine. Now, for someone that might be listening and checks out your website and sees the project that you do, and then say, "Oh, well, I just designed a 4-story cube or whatever it is." Do you think there's still a benefit in being in that those design discussions early in the conceptual phase if you're doing something that's more ordinary?
Yeah, I guess on our website again, we publish a bunch of our exciting projects, and that's not to say that all projects aren't exciting, but we always try to find something exciting with projects, even if they're a bit more usual or boxy. And so picking your element within a building, even if it's just a small lobby space, trying to find something unique or something that's particularly interesting to yourself, just to motivate yourself to do something unique and something well in that building. But I guess that kind of comes back to one of our approaches is to challenge convention. We look for opportunities to challenge convention in all that we do, and in fact, with new engineers joining, we ask them, to do exactly that. Conventional approaches often, work out, but it doesn't hurt to challenge it and see if there's maybe a new way of doing that.
Yeah. I talked with a principal in a firm in Colorado a little while ago, and he was saying when they bring on new engineers, the way they help them kind of develop their creative side is they'll have a problem that they need to, have some structural detail for. They'll say, okay, here, bring me a solution. When they come with solutions, they say, all right, this will work. Give me 3 others and we'll compare them all. Because, you can't just getting to the solution is not just saying this is the best one.
Yeah. No, that's a good way. There's an exam in the UK, the ISTRAT-D exam, that's really good for engineers to study for and practice, because it basically goes through basically a week's worth of work in one day, and you have to develop a design, a few different schemes, and go through that design and present it to a client, and even write a letter about it. And so we found that those encouraging people to take that exam has been good to also help their creativity and schematic design abilities.
Yeah, I've never heard of that exam. We'll have to take a look at it here. If you want to learn more about this exam, the website is istruct.org. That's istructe.org. So, Fast Epp, you have a new office under construction in Vancouver, BC. It's serving as a living laboratory for the firm. There are a number of new technologies being explored here, including dynamic glass, tectonus devices, and CLT firewalls. First, can you give us a high-level view of this building? What are the gravity and lateral systems going on here?
Sure. Yeah. I mean, at a high level, it's a hybrid mass timber building, which just fits so well with us. We're excited to be building this custom building for ourselves, and yeah, it's 4 stories over one below grade structure. Basically, we've prefabricated CLT and glulam beam panels that get lifted onto site. Steel posts that are intumescent painted because we have some different occupancy uses at the ground floor versus the upper levels. That's kind of the gravity system. We've even mixed in some NLT or nail laminated timber in the stairs just to kind of showcase different materials in the building, because we're hoping that clients will come over and we can walk them around and show them different things. But basically, it's an exposed structure with the hybrid feel, get the warmth of the wood, biophilia of that material. And the dynamic glass is exciting. I'm excited to see how that works out. Just a glass that darkens and blocks out UVs. There's some interesting studies about how it may even impact or improve sleep. So we'll see if we're all sleeping better in a year's time from that. But, yeah, so the CLT itself is acting as the diaphragm. We've just got concrete topping over that with an acoustic mat. But the lateral system is really interesting. It's a mix of CLT shear walls, some steel braces, and the CLT shear walls are not completely codified, both in Canada and the US. There's different ways of dealing with the energy absorption, and so we're using a product called tectonus from New Zealand, which is essentially a self-centering energy dissipation device that goes at each end of the shear wall. We take out shear with typical clips at the bottoms of the walls, but the overturning is really where the energy absorption comes from. And so this tectonus steel shoe essentially absorbs energy and self-centers after the earthquake or cycles through that. So I believe it's the first use in North America and should really help our resiliency, our building seismic resiliency for that. And I guess the last point is you mentioned the firewall or the perimeter shear wall. So just with the property adjacencies, we've had to put in a firewall, and we're using a CLT wall that's not only taking shear, but provides that fire resistance through some charring. And it's pretty cool that we've been able to prefabricate that with the insulation, with membrane, with the Z-girts, all of that in a shop before it's erected to site. So we don't have to go into the neighbor's property and start tacking that stuff on. So it's kind of a fun kit of parts solution to this building.
That's cool. Do you think a rocking wall kind of system is the way this will all shuffle out for the kind of the best CLT shear wall designs?
Yeah, it really depends on where you are. In a high seismic zone, you do need something that absorbs energy, self-centering, but also simple to install, which we're hoping this tectonus system proves out. Whereas we're doing the project in Arkansas right now, lower seismic zone, still seismically controlled though, and there the ductility isn't as much of a factor. Mm-hmm. So yeah, depends on where you are in the country.
Good point. Cool.
So it seems that we're seeing kind of this big flood of mass timber to the northwest and Canada being used to design buildings as a construction material. Why do you think this is coming kind of back to the forefront, and why now?
Yeah. That's a really good question because, at the turn of the century, I mean, mass timber was done. They didn't call it mass timber back then. It was just regular floor decks, but those were thick NLT or 4x12s or 3x12s of old growth wood, and basically it was an abundance of material back then with low labor costs, and now with obviously much higher labor costs. Mass timber is a great solution because you can prefabricate this, reduce time on site, get things built faster. So labor costs, I think, is one component. The CNC technology, BIM, the fact that these are prefabricated large panels, all plays into it as well. And the speed of erection on site, is close to unparalleled. We had our 18-story Brock Commons project here in Vancouver that went up in 9 weeks. That's after the concrete cores and concrete podium were in place. But this is very fast construction, and also quiet. Like these are small crews. 8 people, maybe as much as 10 people, and they're using hammers, not drills and saws to deal with some of that noisy stuff. So that's a big reason. And then I guess finally is really the sustainability side. CO2 reduction, carbon sequestration, timber being the only real building material that's a renewable resource, primary building material that's a renewable resource, is a big bonus for sure. With more grown than harvested, there's certainly some room for improvement of how the wood is harvested, but especially when you compare it in a life cycle analysis or whole building life cycle analysis, the wood is still a leader when compared to others.
Having done CLT designs in both Canada and the US, do you see any differences or challenges in doing it in one country versus the other?
Yeah. Canadian code allows for a bit more flexibility, and relies a bit more on engineering judgment and analysis, which has been a bit of a relief, coming here from the States, originally from Utah. And U.S. codes are they take a very prescriptive approach, and that's fine, but it does limit some of that envelope pushing that we like to do. So with the U.S. warring to mass timber, NLT, GLT, or glue laminated timber, I should add, has been in codes for decades, but with the IBC 2015 adopting CLT, it's really coming to the forefront. And as we were just saying, with the shear walls and braces, there's a lot of room that needs to be adopted within the codes there. But in the meantime, we're just working with the authorities having jurisdictions or AHJs to get those components or elements into buildings before it may be adopted. And again, that's based on just engineering fundamentals and analysis and just peer review in some cases to prove it out to them. But yeah, in general, Canadian codes are a little more flexible that way.
Yeah, that was kind of our assumption when we were thinking of that question. So Max and I have talked to quite a bit of people, more mostly off the show, about mass timber and both building it and designing it. And kind of the two complaints that we hear is that it's really hard to determine floor vibrations or to predict them. And then also, as you already touched upon, the lateral system, it can be very challenging especially in high sizing, to find that ductility. So the new home office seems to tackle both of these concerns. Could you tell us a little bit about how you're mitigating or not mitigating floor vibrations for the new building?
Yeah. As you said, it's difficult. Vibrations really depend on the perception of the occupant. One person might find something bouncy, and the other person's totally fine with it. But there's software that we use to analyze the vibrations, and we have vibration sensitive equipment that we go in after the building is done and test that to see how it compares. And oftentimes it's better than what our analysis shows, given some of the additional damping that might be there, or partition walls or furniture, that sort of thing. But it's still a pretty hard thing to pin down. We're co-authoring the mass timber vibration design guide that should be out fairly soon for the US and Canada. So that should help designers, at least with some rules of thumb and some more detailed analysis on how to do that. But timber is more susceptible to vibrations than concrete, say, but not that much more than steel. And basically, we deal with it just through added stiffness, whether you need to go deeper or maybe introduction of composites with a floor topping. That's a good way. So adding depth means more wood volume, and wood volume adds cost. That's a big portion of your cost is the volume of wood itself. And so composites may make sense. Really depends on if you're tied on ceiling height as well. Composites help thin that up and provide that extra stiffness. But with our home office, we are pushing the limits of bouncy. We actually kind of hope that it is a little bouncy, because we want to think of our office as a bit of a research testing lab and testing these various components. Good to bring clients in and say, okay, is this floor too bouncy for you? It's 4 hertz or whatever the case is. Does this feel okay? And if it turns out that it's maybe making people sick, or people are being annoyed by it, then we have some ideas about putting in some remedial dampers, some tuned dampers that we might even be able to tweak the floor frequencies and play with that a bit, which would be really fun, I think, for people to see.
Yeah, absolutely. That is so cool. You mentioned it briefly, but what's Fast Epp's experience with composite concrete over mass timber deck, as it seems to be a popular solution to floor vibrations right now? Do you see that as kind of the best solution?
Yeah, I mean, concrete composites, you have to be a little careful about how you do it. We've heard of some cases, where you're adding a bunch of elements that stick up above the floor and it creates tripping hazards. Maybe they're sharp elements. And so I guess our first approach is, if we're not constricted on height, then we'll just do it straight with the structure itself, especially if there's an acoustic mat that maybe prevents or restricts the composite nature of that. You still can get some composite going through the mats. As we're doing some testing right now, we've got some grants that have allowed us to do some testing on these composites. But yeah, it's an effective way to keep the materials down and to provide stiffness. So it definitely should be a tool in your toolbox.
Absolutely. I'm curious, do you guys have an in-house lab at all when you're doing these tests, or is this you run the finite element and bring it to a university to do real life-size tests? Yeah,
we're usually working with universities, although there's talk about dedicating a portion of our new office to lab space itself, and maybe doing some of these testing just in-house, more so out of curiosity and seeing how far we can push the envelope before we take it to an official level. But yeah, universities we're working with a number of them across Canada and the US.
Very cool.
So this one wasn't on there, but I just remembered you guys did some testing looking at using double T's made out of mass timber. What was the drive of that system?
Yeah, it's basically double T's are, or I should say, purlins or beams with deck is a really great way to reduce the total wood volume of your system. You can span 20 feet with a thick ply CLT or any mass timber element, but if you add purlins, then you can get the total wood volume down. But then you're lifting more pieces in. And so the idea behind double T's, similar to the precast industry, is to just prefabricate these offsite, get composite action with the ribs and the deck, and in some cases, again, back to integration and holistic design, maybe putting acoustic clouds, lighting, sprinklers, plumbing into those panels, and dropping them in, plugging them in, plug and play essentially, and have your system all done. So that's a big motivation for prefab and double T's in general.
That's awesome. Yeah, I saw that on your guys's I think LinkedIn. There's an article about it, and thought that was such a cool, brilliant system. So
yeah, thanks.
So with mass timber being a commodity product, the size of mass timber bays plays a large role in the cost and ability or availability of the panels. How does Fast Epp optimize panel layout for limit states and also availability?
Yeah, so we found that we were doing basically the same study or prelim design for project after project, and realizing that while you can borrow some sketches here and there, it made more sense to build some tools. And so we did an in-house parametric tool using Grasshopper, and basically it allows us to look at different spans, whether you have purlins or flat deck beams. Point supported CLT is a consideration given the two-way nature of it. Also looking at fire rating, building height, and all of that ultimately boiling down to cost. So using these different systems, we can basically quickly come to a conclusion of what system makes the most sense for a specific project and different spans.
So it's rare that a structural engineering company has a software division. I mean, I assume very, very rare. I've not ever heard of this. How did this come about, and how do you utilize the tools they create to be more efficient or more creative in your design?
Yeah, so that is through our ideas lab, or ideas incubator group, where we've thrown out some ideas. It started with our concept lab app that just really takes a high level approach to member depths for different spans of concrete, steel, and wood. But more recently, we've been developing this parametric tool for both in-house, which is a more detailed analysis, but also we've posted a more simplified version called the Timber Bay tool to our website. And that really came about because we've hired some really great young engineers that understand Grasshopper and this new form of programming, which frankly kind of goes over my head. It's really interesting and great to see. And so, getting those right people in place to throw out those ideas and push and pull some of this in-house software building has been really fun, really exciting. So the Timber Bay tool and the in-house parametric modeling tool again allows us to do early design with architects, developers, maybe even just a study to test whether or not mass timber has some validity in a project, and come to a grid for the designers to help inform their building layout. So doing that virtually in real time through an hour or two meeting, you can walk out with some good assurances that you know what's going on with the building, or at least the structure.
Yeah. So I have to ask, I think, and a big reason we do this show is structural engineers tend to kind of keep their deck close to their, what's the term, their hand close. They don't show what they're doing. But you guys provide this, free on your website, not the full in-house version of this, but you just provide this as a service that anybody could use. What makes you want to do that?
Yeah, well, I think it's just collaborating in general. We want architects, developers to be able to test things out and look at the buildings maybe before they call us. We understand that other engineers may use it too, and that's fine. I mean, it's just furthering the mass timber industry in North America, which is close to our heart for sustainability reasons. And mass timber isn't rocket science. There are certainly some nuances that I think that we have learned over the years, but getting more timber design into the world, I think, is a big driver for us.
Seems like a great reason.
Yeah.
So with us being located here in the States, you're up in Canada, to use the software on your website, is there anything that is affected by the US versus the Canadian code that's kind of built into your guys' program?
Yeah, the online tool is really a preliminary design tool. You can't print it out and throw your stamp on it and send it to the building department, obviously. So we have based it on Canadian codes primarily, although they are very applicable to the US from a preliminary design standpoint. So yeah, it can be used for both, but I think currently we just have a metric, and so the Americans may need to pull out their calculator and their conversion tools to convert over to imperial, but we're hoping to get that in the tool quickly here.
That's a big ask.
Yeah. Yeah.
All right. Well, so going back to the new headquarters, I think. Can you tell us more about the lateral system chosen for the office and why you decided on Tectonus?
Yeah, it's really about just innovation and finding new ways of doing things. Mass timber hasn't been around that long, but there is a convention for the lateral system that's starting to build, and so again, challenging that convention by introducing new elements. We always love to explore whenever we can. And so, Tectonus came in and gave us a short 1 hour presentation. And by the end of it, we were licking our lips and excited to use it on our project. So it just seems to work very well with our layout. As well, we're exposing these elements, these hold down elements at the ends of the walls, so that people walking down the street, they look into our building and they can see something unique is going on there. So we're hoping it just draws more attention to engineering in general and what can be done in the mass timber lateral world.
Yeah, I was looking on the Tectonus website, and for anyone that hasn't seen them, they should go on that site. It's a slick site, number one. The system just looks beautiful, and it's really, really clever. So I hope it gets some more use.
So we talked a bit about collaborating with the architect and getting in early. The first thing that came to mind is this mass timber is this beautiful system that's supposed to be architecturally, exposed and used as the architecture. The first thing that hits me is, where is all the MEP going? So how do you guys look at the mechanical systems and the plumbing systems to be integrated with it to still deliver what the architect's looking for?
Yeah. I often say that we can spend days, months on detailing a beautiful exposed mass timber structure. But then the mechanical guys, or trades, I should say, come in and put up big ducts, and so it sometimes hurts the success, in our opinion, of the building. And so we want to work with certainly the mechanical, electrical consultants from an integrated collaboration standpoint to get those elements tucked up into the structure, even if they're within the depth of the structure, between purlins or beams. Just doing that goes a long way to hide those elements. You can imagine looking down a long hallway and sure, if you look straight up, you'll see sprinklers and pipes, but the further you look down, you just see the underside of these wood ribs, which is a nice effect. But it really depends on the type of building, whether it's residential, commercial, about where is best to hide or integrate those elements, whether it's a residential hallway and then branch off, or maybe pop straight down from the roof, or even pulling columns away from the facade a little bit to run some mechanical there, or hiding it between double girders potentially. So there's a bunch of ideas there, but I do want to just touch on a lot of the mass timber buildings we do are exposed, but with the new 2021 IBC provisions and many early adopters that are out there, with the taller buildings, once you get above the 8 stories, then we're looking at partially encapsulated mass timber, and getting above 12 stories, you're into fully encapsulated, meaning that we're putting drywall and Type X fire treatment to all elements in some cases. So none of it's exposed, which allows us to hide mechanical, electrical a bit more, but not necessarily to expose the structure, but just to, again, integrate things. There's still a lot of benefits to mass timber itself, so we're not too heartbroken when we can't expose it, but it's always nice if we can.
So are you seeing, I guess, the one thing that to me would jump out is maybe, and it's an expensive probably option, but maybe using like a raised floor system, an elevated kind of platform to run all your mechanical space through. Are you seeing that being used?
Yeah, raised floor, it does add a fair bit of cost. We've had a number of projects that use that, and it makes a lot of sense if you need a lot of flexibility, future flexibility. Smaller meeting rooms that need air supply, so that you can run it under the floor. But what we're seeing a bit more and more of is just data floors, a 3 or 4 inch raised data floor that you can run all of your electrical and data within that, to provide flexibility to move desks around. That's been a nice way to hide that, but you still obviously have the ducting that needs to be integrated in the ceiling above, and more so fixed conference rooms and smaller blocked off rooms in commercial buildings, obviously.
Okay.
So what do you think the field of structural engineering and construction as a whole will look like 20 years from now?
Yeah, I know we have been talking a fair bit about mass timber, but I would hope and think that mass timber will just be a standard building material, just another tool in everybody's tool belt to utilize. Contractors, installers, AHJs becoming more comfortable with it year by year. So I'm hoping maybe that's the case even 10 years from now. But so just more materials, with the composites and carbon fiber materials that are out there you see on some buildings. We've proposed it on a few. It's obviously quite expensive at this point, but I could see those new type of materials being used more readily, and again, making things just more delicate, more elegant as time goes on. Software analysis tools obviously are just on the rise right now with BIM 360, and the collaboration with architects. So software development is going to be a whole new thing in 20 years. Maybe with some VR thrown in there too. Building these blocks with headsets, that'd be pretty cool.
Oh yeah, absolutely. Do you think we'll see in general just more prefab systems, or the existing ones becoming used a little more?
Yeah, I think prefabrication is going to be a big part of it for sure. We need to become more efficient at building things, and that's often done in weather protected environments, comfortable environments for workers. And so kit of parts, which we often do, even getting to volumetric modular prefabricated kitchens, bathrooms, all of that is starting to come into the market, become more standard, and we'll see more of that in the next decade, I think.
So one thing we really like asking other engineers is, And what do you think are good traits, or are the traits of a good structural engineer?
Well, I mean, it always starts with engineering fundamentals. You have to have a good rooted understanding of those engineering fundamentals. So pay attention in your early engineering classes, because that will help you throughout your career. You can always revert back to those statics questions or equations. Programming and this grasshopper approach to programming, I think, is certainly going to become more prevalent and open up some new ways of doing things, more efficient ways of doing things. So, that certainly wasn't part of my curriculum in your university, and I'm hoping that it will become more as the days go on. But I'd also say, just through coordination and BIM. There's a lot that at least our engineers aren't doing right now with the drafting and collaboration with these BIM models that we're starting to do more and more, and I think the industry in general is doing more and more. But there's a lot of room to grow into that field for sure.
Absolutely. Following up on that, what advice would you give someone, let's say, graduating now, on finding the right firm to work for? I would say graduating now, but not now in a pandemic. Now,
yeah,
on finding the right firm to work for and starting on the right foot to a rewarding career.
Yeah, well, I mean, first start to get to know the engineering firms that you may have the chance to work for, and find one that's obviously interesting to yourself and aligned with your goals. There's just small nuances between firms that some do one thing and somebody else does another. So do a little bit of research, maybe shadow some of the engineers, start talking to them and seeing which aligns again with the way you want to go in life. Head down, hard work right when you get into the job, that will pay itself tenfold to continue to just build your foundation. Early days, many engineers will get pulled into project management or keep getting promoted because they are doing such a good job, but they almost get promoted out of what they're good at. And so, keeping sight of that technical side, that foundation that you've built, for your first 5-10 years, is important. Keeping your head in the codes and finger on the technical pulse is good.
Yeah, I think that's really excellent advice. So many people, after their first couple of years, want that manager title or something like it. It feels like the logical progression, but it's not necessarily the best move right off the bat. It's not. There's a lot to learn on the lower side, and it'll make you a lot better in the end.
Yeah, too true.
One question I wanted to ask, and I think this doesn't have to be in the episode, but Max and I were talking about this the other day after we chatted with you, and it's something that not most firms or anyone wants to talk about, but is fees and money and things like that. It sounds like you guys go beyond the scope of what I would say most projects probably I work on, and Max with being in there super early and working through many iterations. Is that something that you guys find with your clients is easy to work through, or how does that work? And again, if you don't want to talk about this, totally okay.
Yeah, no. Yeah, so I'd say in general, we try to keep respectable fees for the work that we do, and from a client perspective, spending maybe just a little bit more on your engineer will come back in fold with the savings that a refined design will have. If an engineer goes in with a really tight fee, they don't have time to refine that slab down from 12 inches to maybe 11 inches or reduce the reinforcing in the slab. And so I think the clients and architects that we work with understand that we do go that extra mile to help the total costs come down. But in engineering, structural engineering in general, we're taking on life safety issues, and so just want to make sure that the industry in general is paid properly for that for that liability that everybody takes on.
I like that yeah, you bring that value added and your clients can respect that. I think that's a great answer.
Close it down.
Yeah, thank you for joining us this week on the podcast. Really appreciate your time and your insight in the industry.
Yeah, it's been my pleasure. It's been great chatting with you guys, and best of luck in everything you do.
Thank you.
Thanks.